Thank you for joining us. Let's look in this video at how to use Ruffini's rule, otherwise known as synthetic division. And what Ruffini's rule, synthetic division, allows us to do is to have an expedited way of determining the quotient and the remainder when a polynomial is divided by a linear term. This is important that our synthetic division only works if I'm dividing by a linear term. So let us go ahead and go through the mathematics. So we're going to use Ruffini's rule to find the quotient or the remainder when f is divided by g. All right, and remember, only use if we're dividing by a linear expression. So synthetic division, Ruffini's rule, linear expression. So x plus 2 linear, x minus 5 is linear. So how we'll set it up, we'll look at what we're dividing by, whatever this is, and say when would that equal 0. For the first one would be equal to 0 at -2. For this one over here, if we look at it, this x minus 5 would be equal to 0 if x was equal to 5. Then we're going to take our coefficients in sequential order and write them down. So we have, for this first one, 3 for x cubed, then 11, then -7, and then -19. Okay. For this one over here, we're going to go in sequential order. We have our x cubed term, which is 4. We have no x squared term, so I'm going to write the 0 to represent the x squared term, that there's no x squared term. Then I'm going to have the linear term. Then I'm going to have my constant term. All right, so that's my initial setup. So how's this going to work? I'm going to take this 3, all right, and I'm going to bring it right down, so I'm going to have a 3. Then -2 times 3, -6. Then I'm going to add coming down the column, that's 5. Multiply, -2 times 5, that's going to be -10. Add coming down the column, that's going to be -17. Okay, and then I will multiply once again, -2 times -17, that would be +34. Then +34 and -19, if I add that, that's going to be 15. So this at the end is my remainder. And if I think about this as x to the 0, x to the first power, x squared, just increasing by my powers by 1, I know my quotient as well. So the quotient for this first situation is going to be 3x squared plus 5x minus 17. And my remainder is going to be 15. Right? Because I have a remainder, right? Because I have a remainder, I know from the factor theorem that f of -2 is going to be equal to 15. So useful piece from the factor theorem for us. Right? Or rather the remainder theorem, excuse me, right? That the remainder is 15 when I evaluate at -2. So I know that x plus 2 is not a factor. Okay? If I look to the part B, or question B, 6B, I have, once again, the 4, 0, -3, and 8, because I have to keep everything in order. No x squared term, I still need to keep the 0. Bring down the 4, all right? So I have a 4, 5 times 4, that's going to be 20. Add, that's going to be 20. 5 times 20, that's going to be 100. Add, that's going to be 97. 5 times 97, that's like 5 times 100, which would be 5 times 100 would be 500, then minus 3 times 5, so this would be 485. Then 8 and 485 would be 493. All right. If the numbers are particularly large, maybe you'll have a calculator for this, but these are fairly reasonable to be able to compute. So we want the quotient and the remainder. So that tells us that the quotient, right, is going to be with these, right? So I have x to the 0, x to the first, x squared. If I had more terms, I would keep that going. So this is going to be 4x squared plus 20x plus 97, right? And I'm going to have a remainder of 493. Right? So that's using synthetic division or Ruffini's rule. Right? It is possible for us to use Ruffini's rule multiple times in a row. Right? So here we have a polynomial and it happens to be cubic, and we're going to say, hey, use synthetic division twice in a row to show x minus 3 and x plus 2 are factors of f of x. Right, so I'll get set up, right, with the x minus 3. I'm going to be using a 3. My coefficients 2, 1, negative 15, and negative 18. All right, bring down the 2, multiply, add, multiply, add, multiply, add, and if that remainder is 0, then I know that x equals 3 is a root, which means x minus 3 is a factor. Like we said, we can do this multiple times in a row, so now let's consider this x plus 2, and so I'm going to put in a negative 2, and I'm going to repeat my process once again. So bring down the 2, multiply, that's negative 4, add, that's 3, multiply, that's negative 6, add, that's 0. So then we know that x plus 2 is also a factor, but of course that's the work that we're doing to show that we have a factor. So how can I write the linear factorization for f of x? I would have the f of x, oops, let's write this a little bit more neatly. I would have the f of x is going to be equal to, right, the first factor, x minus 3, the second factor, x plus 2, and then my last factor, right, so this is going to be my constant, this is going to be my x term. If I had more terms, then I have x squared, x cubed, right, going on. But I stop with just those two, so I'm going to have then 2x plus 3. So that's my linear factorization of f of x, and we call it a linear factorization because f of x is expressed in terms of linear factors. All right. So let's look at one more example. Let's look at one more example using the synthetic division. Okay. So here we have determining the quotient and remainder when this function, this polynomial, is divided by 3x plus 1. Right? So remember, synthetic division only works if I'm going to be dividing by a linear term. And I need to evaluate based on when the divisor is 0. So if I'm dividing by 3x plus 1, this is the divisor. So when is 3x plus 1 0? It's at negative 1/3, so I'm going to use negative 1/3 for this problem. So my setup will be with a negative 1/3, right? And then write my coefficients, in this case 6, negative 7, negative 15, and 1. Okay? Bring down that 6, right? Then multiply. That's going to be negative 2, add negative 9. Then multiply. That's going to be a positive 3. All right, add. That's going to be a negative 12. And then lastly, if I multiply here, that's going to be a 4, and add, that's going to give me a 5. So I know that 3x plus 1 is not a factor of f of x. But my quotient, right, my quotient is going to be 6x squared minus 9x minus 12. And my remainder is going to be 5. Okay. Being able to find that quotient will be useful for us later on when we start discussing rational functions. Being able to find the remainder will also be useful to us in other contexts. Well, Hopefully that made sense for using Ruffini's rule, also known as synthetic division. Thank you for your time.